Hello everyone, welcome back to Technologies Discussion channel. For this video, I'd like to continue the discussion on antenna. This video, I will explain why the length of dipole antenna need to be around half of wavelength. So this will be the key objective of this video. There are in fact two reasons. Firstly, because of impedance matching. Because when dipole antenna is actually at half wavelength, it actually resonant, and therefore the reactance will be cancelled, and the real impedance will be around just 73 ohm, okay, which is desired. So later on, you will be able to understand why. Next, again, when antenna is actually has a length of about half of wavelength, it actually generates standing wave. This is also ideal for this topic of discussion. So basically, this video, I will explain and highlight why the length of dipole antenna need to be around half of wavelength. This is my email. If you have any question regards on this discussion, please drop me an email, okay? Or if not, I actually prefer you guys to ask me your question through the comment. Before I continue, I'd like to urge you guys to help me by like this video. Guys, it's free and it's just a few seconds. Help me. Press the like button now. For those who are new to this channel, and if you want to encourage me, I strongly urge you to consider to subscribe to this channel and turn on your notification bell. Once again, thank you so much for strong support. I'd like to explain why the length of dipole antenna need to be around half of wavelength. Okay, so basically, I will explain step by step so that you can completely understand why. So firstly, for a half wave dipole, okay, so you can see that this is actually a dipole antenna. The length of the dipole antenna, which is around half of wavelength. So because of current distribution, okay, so the current will be maximum at the center of the dipole antenna. Let's take a look on the blue color. Okay, the blue color is actually for current. So from here, you can see that current is basically maximum at the center. As you can see from here, on the other side, the current will be very near to zero at the end of the dipole antenna. So with this, you can look at the end of the dipole antenna, you can see that the current will be very near to zero. This actually create a standing wave pattern, which is desired. So later on, I'm going to show it to you what is actually standing wave pattern. But with half of wavelength conductor, basically they generate standing wave pattern. So this is actually the first reason. Because of standing wave pattern, so therefore the dipole antenna need to be around half of wavelength. The second reason is the current phase will be in phase. So with half of wavelength dipole antenna, you can see from this diagram here, the current in both arms will be in phase, which means that the magnitude, okay, of these two arms, the current flow onto these two arms, they will be in phase. If let's say they are actually out of phase, okay, the radiation pattern may cancel each other. Hence, it is always ideal for them to be in phase. Okay, because once they are in phase, the radiated field will combine constructively, and this in fact will increase the strength of the radiate signal. So this is actually the second reason, because okay, with half of wavelength dipole antenna, we actually create a current that is actually in phase. Earlier on, I mentioned that when dipole antenna, which is around half of wavelength, okay, basically they generate standing wave. Okay, so how they actually generate this standing wave? When RF current actually flow through the antenna wire, as you can see that in blue is actually the current flow along the antenna wire, it actually reflect at the end. Okay, so basically you can see that they actually reflect at the end of the dipole antenna. This actually forms a standing wave pattern. Okay, so on my next slide, I'm going to explain why it is so crucial for us to have a standing wave pattern. On my previous video discussion, I have explained that the radiation for dipole antenna will be maximum when they are actually perpendicular to the dipole antenna. Okay, so basically this is what I have explained based on my previous video. So now this video, I'm going to explain why we need to have a standing wave. From here, you can see that there are actually three types of waveform. The blue one, the green one, and the most critical one will be the red one. The red one, in fact, is a stationary wave. Okay, what does this actually means? Okay, so if you look at the blue one, okay, so you can see that the blue waveform actually shift to the left. And if you look at the green one, they actually shift to the right. But if you take a look on the red one, okay, which is the standing wave, they are so-called the stationary wave because they do not shift to the left or do not shift to the right. So basically, this is why we need the dipole antenna to be half of wavelength. With this, they actually has this standing wave, which means that they radiate maximum at the perpendicular of the dipole antenna. Okay, so basically, this is the reason why dipole antenna need to be half of wavelength. Before I continue, guys, this is very important to me. I hope you can help me by like this video. Guys, when more you guys actually help me to like this video will have a better chances to reach up to a larger audience. So guys, help me. Press the like button now. For those who have learned something from this video, okay, I strongly urge you to help this channel by subscribing to this channel if you have not done so, and also turn on your notification bell. Once again, thank you so much for strong support. Resonance actually occur when the dipole antenna, which is around half of wavelength. What does resonance means? Okay, so when resonant, it simply means that energy transfer from the transmitter to the antenna is actually maximum. Let's take a look on this diagram to understand better. This is a wave. Basically, they transmit from the transmitter to the antenna. So with resonant, which means that majority of the signal will be transferred from the transmitter to the antenna, very little will be reflected back. This is why it is important to be resonant, which means that close to 100% will be able to transfer from the transmitter to the antenna, and very little will be reflected back. So basically with resonant, okay, basically the antenna will be required to be half of wavelength. Okay, so basically this is the explanation. At half a wavelength long, the antenna in fact act like an open transmission line that is actually due to the desired frequency. This actually cancel out all the electrical reactance, can make it simple to connect to any standard radio equipment. In a dipole, a standing wave developed, which I have explained early on. The voltage actually peak at the end, while current peak at the center. This in fact will give a purely resistive impedance of around 73 ohms. Let me do a summarized discussion. Okay, so when dipole antenna is about half of wavelength long, the current distribution will be ideal. The radiate resistance will be around 73 ohm, and with the resonant, okay, basically the transmitter is able to convert almost 100% to the antenna. This will have some radiate wave efficiency. So this is the reason why dipole antenna need to be around half of wavelength long. Let's quickly understand, okay, why optimum current distribution is ideal. As you can see from this diagram here, you can see that when dipole antenna, which is half of wavelength long, you can see that they actually create a hump from here. They actually form a hump, which is a standing wave with maximum current at the feed point, okay, which is at the center, and zero at the end. You can see that when we actually increase the length slightly, okay, basically the effect may be cancel each other. So in short, okay, it is always preferred to have the length of the dipole antenna to be around half of wavelength long. Coming to my last slide for today's presentation, okay, because of practical size, okay, so therefore we prefer the dipole antenna to be around half of wavelength, because a full wave antenna, they are probably too large for some application. While on the other hand, okay, a very short antenna, they basically will be radiate very poorly. They are not efficient to transmit all the EM wave into the air. So hence, lambda over 2 dipole antenna actually provide a good balance between size and efficiency. In simple word, a dipole antenna which is half a wavelength long, because that length actually allows standing wave and resonant to occur, this in fact produce maximum radiation efficiency. With this, I'd like to end my discussion. Please help me to like this video and subscribe to this channel. Once again, thank you so much for strong support. I hope to see you guys soon. Bye for now. Thank you so much.